be simplifying the trig expressions. What does it mean to simplify? Reduce it down, yeah, to like the simplest form or the lowest form. So for us, the two big things that we're going to be looking at is we want the least amount of trig functions and the least amount of operations. So because we're dealing with trig expressions, most of the time we are not going to be able to simplify it down to like a single number. Does that make sense? So we're still going to have stuff that has trig stuff in it, okay? But we're looking at making it like smaller or less complicated depending upon what they give us originally. So we're looking at, that's just to simplify. On our first one, I have a sine times a cotangent. So we have the multiplication, and we have two different trig functions. So our goal would be to have less operations, so maybe to get rid of that multiplication, and to have less trig functions, so to potentially only have one trig function instead of two. Are we all with me? Okay. Now, remember that these are expressions, meaning that they are not equations. So I cannot subtract, multiply, or divide by stuff because I don't have two sides of an equation. So if I were to add, subtract, multiply, or divide by stuff, okay, I would be changing the value or what it's equal to. And so then we can't put an equal sign as we go down. Are we all with me there? So that's where the trig identities come in play, because all of our trig identities are equations and they are equivalent, meaning that if I have like A equals B and I have A in my equation, or sorry, in my expression, I can substitute B wherever I want. Does that make sense? So our goal is to look at what we have. So right now we have a sine and a cotangent, and to look at our trig identities and say, okay, which one of our identities has a sine and a cotangent in it? So we're going to look at our identities. Which reciprocal? So like both sine and cotangent have a reciprocal identity, but I'm trying to look at one that maybe has both of those in them. So group 4, which one of our trig identities has both a sine and a cotangent in it? Just looking at the thing. Which one of our things has a sine and a cotangent in it? Yeah, our quotient identity has both a sine and a cotangent. It tells us that cotangent equals cosine over sine, which means that because the cotangent equals that, I'm allowed to substitute cosine over sine into my expression. Yes? Now, what do we notice we can do now?
We can reduce
To
cosine.
correct. So sine divided by sine gives us 1. And so then we're just left with a cosine of x. So did I get rid of my multiplication?
Yes.
Yeah. Do I only have one trig function now?
Yeah.
Yeah. So we have simplified it as much as is possible. So that's my answer. Now, what do we notice about the next one?
The sine and the cotangent are squared.
They are. Now, which set of our identities has stuff that's being squared? Our have ones and have trig functions in them. So which one of our trig functions has a 1 and a cotangent squared in it?
Tangent? Or reciprocal tangent?
So we said we're looking at our
Pythagorean.
Pythagorean, but we have 3 Pythagorean. We have sine squared plus cosine squared equals 1. Well, my sine squared on the outside doesn't have a cosine squared or a 1 with it right now. So that one's not going to be super helpful. Our next one is what?
Sine squared over cosine squared plus cosine squared over cosine squared equals 1.
Yeah, what's the reduced form all the way down?
Tangent plus 1 equals secant.
So tangent squared plus 1 equals secant squared. Yes? Do I have a tangent squared or a secant squared? No. So it's going to be my last one, which is 1 plus cotangent squared equals what?
Cosecant squared.
Cosecant squared. Okay. Now, is there another identity that relates our secant, sorry, our cosecant and our sine?
1 over the 1 over cosecant equals sine.
Oh, equals sine. Okay. We'll go that way. So that means that if I have a sine squared, basically we have 2 of those. So instead of being 1 over cosecant, we're going to be 1 over cosecant squared. And remind me, what's that identity called?
Reciprocal.
The reciprocal identity. Are we all agree with that? So then what is 1 over cosecant squared times cosecant squared?
1.
So in this case, we do just end up with a number. Okay. So is 1 simpler than sine squared times 1 plus cotangent squared? Yeah. What questions do we have on those two? And again, you are going to need those 3 groups of identities memorized by our test, which is next Friday. Alright. Next up, I have sine of x times cosine squared of x minus sine. Now, just so you know, I have like a dot there, or like the last one I had like the x meaning multiplication, but also if you just see them next to each other, it's like xy, right? It's understood that they're being multiplied to each other. Yes? Alright, so on this one, what do we want to do first? Can you what?
Break up cosine and sine.
Can you what?
Break up cosine and sine.
What do you mean?
Reduce cosine out of it.
Can you just take out sine and put the rest of it?
What do you mean by take out?
Factor.
Ah, okay. I do agree. You can factor out a sine. Why can't I just like do sine minus sine is 0 and get rid of them?
Because it's sine times cosine.
Ah. So another way to think about it would be like if I had x times y squared minus x. Yes? The x and the y squared are being multiplied together, which means they are one term. Okay, and I can only combine common terms, which means that I cannot subtract them. Yes? However, we can factor it. So we can pull that x out in this case. Or, like in this one, we can factor out the sign instead. Which is helpful because now what are we left with on the inside? There is a number, there's a 1. What else? What's before the 1? Cosine squared. Okay, so which one of our identities has a cosine squared and a 1 in it? So sometimes we do have to rewrite our identities in order to be able to plug in. So notice that right now we have a cosine squared. You with me? So we're going to try and solve for cosine squared in my equation. So what would I do to get cosine squared by itself?
Subtract it.
Subtract, what is it?
Cosine squared.
I'm trying to get the cosine squared by itself though.
Oh, subtract sine squared.
There you go. Sine squared. So we know that cosine squared is 1 minus sine squared. Yes? So now am I allowed to substitute 1 minus sine squared for my cosine squared? Yes. But remember that part just replaces the cosine squared. I still have a minus 1 inside. Yes? So what is 1 then minus 1?
0.
0. And what are we left with on the inside there?
Negative cosine squared.
That's not a cosine.
Or sine squared.
Okay. Now if I have something to the first power times something to the second power, but the somethings are the same, what do I end up with? Something to the third power, yes? So sine of x times sine squared of x is going to give us
Sine cubed.
sine cubed. But we do have a negative, okay, so that negative is going to have to stay at the front. Yes? So how we started with 2 different trig functions and now we only have
No.
1. We also started with like 3, right? We had multiplication and exponent and subtraction operations, and now we're just down to
Exponent.
1 exponent. So we have simplified it, and that's going to be our answer. What questions do we have on this one? Are we awake today? The weather is so much nicer. We should feel like energized, right?
We are indoors. It feels the same. We are indoors. Oh, blinds work. Blinds work. Flash make this more tasty.
Alright, next one. We have sine of t plus cotangent of t times cosine of t. So how many trig functions are we starting with this time?
3.
3. Okay. So let's kind of go through what we've done so far. Do we have anything that we can factor out this time? We can't factor out a t. Cause so like think of remember your sine, cosine, tangent, or cotangent are all operations. Yes? So it would be like if I had a square root, yes? I can't take the t out of a square root. I can't take the t out of my trig functions either. So do I have any common trig functions that we can factor out?
No.
No. Okay. Do we have any squareds where we could use our Pythagorean identity?
No.
No. Okay. Do I have an identity that has like all 3 of those trig functions in them?
No. Or maybe.
Yes.
Sure.
Which one?
Quotient identity.
Yeah, our quotient identity tells us that cotangent of t equals what?
1 over tangent.
That would be the reciprocal. We're using the quotient. It tells us that cotangent of t equals, we've already used it before,
No, cosine over sine.
cosine over sine. Now, this time, do my 2 cosines reduce out? No, because where are they? They're both on the top, yes? So like my normal algebra rules still apply. So if they are both on the top, what can we do with them instead?
Cosine of t squared. Or cosine squared t.
Correct, we can multiply them. So we have cosine squared on top, and then we still have a sine t on bottom. Yes? Okay, what can we do next? I wouldn't as it is. I do notice that we have a cosine squared, so we'll probably end up using a Pythagorean somewhere. So that's a common mistake. What do we normally do when we have things that are being added and we have a fraction?
Try and get common denominators.
Yeah. So what is the denominator of our first one right now?
1.
What's the denominator of our second one?
Sine.
Sine. So what's our common denominator going to be? So what do I need to multiply that first one by?
Sine.
Just one sine?
No, sine over sine.
Sine over sine. Because remember, the only way for me to not change my value is technically this is multiplying by
1.
1. So that's not changing my value. So we're allowed to multiply by stuff as long as it's a strategic one. So what do we get on top?
Sine squared.
Sine squared. And it's now over sine. So now that our denominators are the same, what can we do?
Add.
Okay. So now I have sine squared plus cosine squared on top and a sine on bottom. What is sine squared plus cosine squared?
1.
By our
Pythagorean identity.
Pythagorean identity. So we did end up using that Pythagorean identity.
And that's equal to cosecant.
That is equal to cosecant. Using the reciprocal. So we took two operations and got rid of both of them, and we took three trig functions and made them into one. So the reason why I like trig identities is because it's kind of like a puzzle. You're trying to figure out the different identities that you have to use in order to kind of make all the things fit how you need them to fit. What questions do we have here? Okay. Now, I will say that your steps for these types of problems are going to be even more important. Okay. One, that way if you need to like go back and fix something, it's easy for you to go back. And two, I will be rating all of your steps. Okay. Because a lot of times there is more than one way to get to a final answer. So as long as you're using your identities correctly, okay, your steps might look slightly different than somebody else's, which is fine. But that doesn't mean I need to see your steps in order to give you credit. So let's look at one more. So what do our direction tell us to do this time?
Rewrite the expression so it's not a fraction.
Cool, right? So they're different than simplifying this time. Yes? We're trying to get rid of the fraction. So what are some ideas?
Multiply by its reciprocal.
But it's reciprocal?
Yeah.
So like 1 plus sine of x?
Hey, well, that should be 1.
It will, but am I allowed to just multiply by something?
Mm-hmm.
Because that would change the value of it, yes?
If you did 1 plus whatever x over 1. Oh, wait.
Over 1
So-
plus.
Don't you have to do the
So like we can only multiply by something if we multiply it to the top and the bottom.
Oh, okay.
Because then that is 1.
Yeah.
But what was your...
it's like you multiply it by like 1 minus sine x over 1 minus sine x. What's that called?
What is that called?
I don't know.
Does anyone remember?
The inverse.
Does
What
it
I-
start with an N?
Starts with a C.
Oh, conjugate.
It is the conjugate. So remember that we looked at complex conjugates when we did imaginary numbers and rational conjugates when we had square roots and stuff, okay? We're going to do a similar thing here. We want to multiply the top and the bottom by a 1 minus sine of x. So because we're multiplying by the top and the bottom, we are not changing the value because we're multiplying by a 1. Yes?
Mm-hmm.
And what's going to be nice is on bottom, notice now, if I multiply this out, okay, what is 1 times 1? 1.
1.
And what is 1 times a negative sine of x?
Negative sine of x.
And sine times a positive 1 is sine of x. So if I have a negative sine of x and a positive sine of x, what do we get?
0.
0. So that middle term goes away, which is why we like the conjugates for all of the things that we do. And then what is sine times negative sine?
Sine.
Negative sine
X.
nope.
Squared.
Squared, right? Because if they're both to the first power and I multiply them, I now have something to the second power. We all agree? Now, what do we think might be a common mistake at this point? Yeah, well, to cancel out one of the signs as well as to cancel out the ones, right? People just like start slashing things because it makes them feel better inside, right? They're like, oh, the ones go away, and then I can also reduce one of the signs, so I'm just left with a 1 over sign, which is cosecant. That is not the answer. Why are we not allowed to just start like slashing things? Because we have subtraction. Are we all okay with that? That the only time we can reduce things is when we are multiplying. Alright. But what does our denominator look like? Huh? Just the denominator. We have a fraction. So what is just my denominator? It's one of my Pythagorean identities. So again, remember. So we have sine squared plus cosine squared equals what? 1. Now, notice, we did this a second ago, right? We subtracted sine squared to both sides. Yes? If we do that again, what does 1 minus sine squared equal?
Cosine squared.
Cosine squared. So what can we substitute our denominator for?
Cosine squared.
Cosine squared. Do I still have a fraction?
Yes.
Yes. So are we done?
No.
No. Okay. So how might I get rid of the fraction now? Or simplify the fraction?
Take the reciprocal of cosine squared.
Multiply by cosine squared over cosine squared.
I would not.
Why?
Because that is not going to make it more simple. That's just going to add in extra cosines.
Couldn't the cosine squared turn into secant squared?
Part of it can. The 1 divided by cosine squared can.
Yeah.
Okay? But what would I also have to have, though, then? So, I can have that, right? That's going to be from my first term. But then what would we also have to have still? Yeah, so I can split this apart as long as we divide both pieces by a cosine squared. Yes? Why could I not split apart my original one and say it's 1 divided by 1 plus 1 divided by sine? There's addition where?
On the bottom.
Correct. And this time, where is our subtraction?
On the top.
On the top. So if I have two things on top, we can divide them both by the one thing in bottom, but not the other way around. Yes? So now, following what you were saying, we can use our reciprocal identity. What is 1 divided by cosine squared?
Secant squared.
Secant squared. Okay. Do I have a sine divided by cosine in any of my identities? It's our quotient. What does that equal? Tangent. But what's the problem right now?
Cosine squared.
Okay. So are we all okay that I can break apart this into cosine times cosine?
Yeah.
So then my sine divided by cosine, like you said, does equal tangent. And then I still have a 1 divided by cosine left over. Yes?
Mm-hmm.
And what is 1 divided by cosine?
Secant.
Secant. Do I have any more fractions?
No.
No, and that was all of my directions said to do this time, is to get rid of the fraction. So that's my answer.
Wait, what did you get?
Here, if it's helpful, I can write it out like this. Secant squared of x minus sine of x over cosine of x times 1 over cosine of x. So basically, I broke this apart into two things, right? So my sine over cosine turned into my tangent, and my 1 over cosine turned into my secant. Other questions? So for the most part, we kind of talked about some things to look for, right? Like if I have squares, we're probably going to use a Pythagorean. We kind of want to look at what it gives us and see if there's a way that we could relate all of those things together, okay? Or we want to look if I have the same thing in both of my terms, then we might be factoring, right? But there's not a set procedure, this is what we do every single time, okay? You kind of just have to get kind of good at deciphering which identity we want to use when, which takes a little bit of